Okay, so with this one, we're going to try to use our vertex, get it straight from standard form, fill out our table, and then see if we can find the solutions where f of x is equal to g of x graphically. So remember, first step to finding the vertex, just from straight from standard form, we're going to take the opposite of the middle term. So that's going to be the opposite of 6 divided by 2 times the leading coefficient, which is 1, because that's just an x squared, so there's really a 1 in front of it. So that'll be negative 6 over 2, so that's negative 3. So that means our vertex is going to occur at negative 3. And the next thing that we could do, so that's one set of critical point, the vertex. If we wanted another set of critical points, what we could do is attempt to factor this. So we would ask ourselves, is there anything that'll multiply to a negative 7, multiply to that, and will add to give us a 6. So if you go with x is equal to, well, x plus 7 and x minus 1, that will be the factored form of that equation. Now, the only reason that I'm using that is just so I can get my x-intercepts, which will be at negative 7 and 1. So what I could do is maybe put a negative 7 here, put a positive 1 there. All right. So at that point, you always want to try to pick something that's in between. So I'll probably make this negative 5. That's 2 away from my vertex. So I want to go 2 in the other direction. So I'll make this negative 1. And then you just want to pick something outside of your x-intercepts as well. So we could probably make this 2 and make this negative 8. That way everything's the same distance on either side of the vertex. Makes it real easy for us to go back and compute our outputs. All right. So if I go and plug in, so we got, I'm going to do it from the factor form just because it's a little bit faster to do mental math. So if I do negative 3 plus 7 and negative 3 minus 1, well, let's see, that'll be negative 4. That'll be a positive 4. So at negative 3, negative 16 is our vertex. All right. So now we're going to plug in some more values. Let's plug in the negative 1. We're going to switch colors so we can. Well, negative 1 plus 7 is 6. And negative 1 minus 1 is negative 2. So multiply it together, that'll be negative 12, which means this should be negative 12. All right. You go ahead and plug in 1. 1 plus 7 is 8. 1 minus 1 is 0. And we expect that 8 times 0 will be 0 because those are our other critical points. That's where our x-intercepts are. X-intercepts always occur when the y value, the function value is 0. All right, so we got one more. We're going to do 2. So 2 plus 7, that's 9. 2 minus 1 is still 1. So 9 times 1 will be 9. All right. And so remember, we can use the same inputs in the second function, and we probably want to so that we can see if there's an intersection at either of those points. Now remember, g of x is the constant function 9, which means that my output is always going to be 9. Okay, so now that we have our table filled out, we'd be able to graph this. Now, if I want my vertex to show up, I probably shouldn't count by ones on my on my y-axis. So I'm probably going to scale those by 2s. But I'll let the x's stay as a single unit just to make things easy. Well, I take it back. Let's just go with what we got, and I mean, if it doesn't show up, we'll understand why, because what we're looking for is where f of x is equal to f of x and g of x are equal. So if you take a look, you see that that happens at -8, and that also happens at 2. Now, if it didn't happen in my table, I probably would have just gone ahead and graphed them and then seen where things intersect. So what I'll do is graph g of x first, and that'll be up here. So there's my g of x. And as I graph f of x, I know that at -8, f of x is equal to 9, and at +2, it's also equal to 9. So let's see, at -7, it's at 0. At +1, it's at 0. And that's kind of where all the decent plotting ends. But my vertex would occur at -3, which would be somewhere down here. So I could try to slide just a little bit. Okay, a little screen magic. But the main thing I was looking for was where this occurred. So using my table, I was able to see where that occurred, and then I was also able to graph it so that I can see it visually. But that's how you solve using your graph and using all the techniques that we did beforehand.